So in this last section for this lesson, I want to discuss Fisher's exact test. Now look at this little example we have. We have patients who took a placebo drug and patients who took a test drug. And we have patients who improved and patients whose disease remained static. So 5 patients improved, 3 patients remained static, and 4 patients each took the placebo or the test drug. So quite small values there. Now remember I said the chi-square statistic only follows the chi-square distribution if the expected values are quite large. And there's actually this whole rule called Cochrane's rule, and it says if you look at the expected table, that more than 80% of those values in each of those cells have got to be larger than 5, and they definitely all have to be larger than 1. So if there isn't that rule of thumb, then you really can't expect the chi-square test statistic, your sample statistic, really to follow a chi-square distribution. If that is so, you've got a few choices. Number one is redo the study, look at the study again, get the numbers larger. The other thing that you could also do is combine columns and rows. So you might have a contingency table where there are many rows and many columns, and you can combine some of those values, add some of them up. It'll make those tables smaller, but at least you can follow Cochrane's rule then that would state that all the expected values have got to be larger than 1 and at least 80% of them larger than 5. Now there's a lot of mathematics and statistics talk around that rule, and is it really so? But it's probably safe to follow. So if we looked at the expected values table from our example here, you see that at least all of the values are larger than 1, but certainly none of them are larger than 5. So definitely not more than 80% of them are larger than 5. So in this instance, we can't combine all of them. We can't combine some of them at least to get to those kind of values. So we've got to move over to Fisher's exact test. And what Fisher's exact test just asks is how many combinations can you make? How many randomizations would give you those same column and row totals? And then it really uses factorials, and it will give you a p-value that is much more appropriate than you would have gotten under the same circumstances using a chi-square test. Only thing to remember the Fisher's exact t-test, it's going to give you a one-tail p-value, and there isn't really consensus as to how to make this a two-tailed test. Most of the time you can just multiply that by 2, and that would be acceptable though.